All right, let's dive into something really cool today. It's a tool called Metamorf, and it makes a pretty bold claim that it's a complete language factory in a box. Now, building a programming language is famously one of the most complex things you can do in computer science. Metamorf says it can make that whole process radically simple. Let's see if it delivers.
So let me just ask you this. Have you ever been deep in a project coding away and had that thought pop into your head? Man, I wish I could just invent my own language, something perfectly built for the exact problem I'm trying to solve. For most of us, that's kind of where the dream stops, because the reality of doing it has always been, well, incredibly complicated.
And that complication is what we're going to call the language labyrinth. For decades, building a compiler wasn't just one job. Oh no, it was more like trying to wrangle half a dozen totally different complex tools, each with its own quirks and frustrations.
I mean, just look at this. This is the traditional maze you'd have to navigate. You'd start with a lexer generator, maybe something like ANTLR. Then you'd need a totally separate parser generator, like Yak. After that, you'd have to write tons of what we call glue code in a completely different language, C++ or Python maybe, just to get them to talk to each other. And we haven't even gotten to the part where you're wrestling with a build system like CMake and trying to manually stitch the entire toolchain together. It is a mess.
You know, the feeling is a lot like this. Imagine you want to build a custom car, but instead of just designing it, you have to personally go to one factory for the engine, another for the chassis, a third for the electronics, and they all use different bolts. Then you have to figure out how it all fits together and literally write the assembly manual from scratch. It's just exhausting, and it's a massive barrier for anyone who just has a cool idea.
Okay, so what if we could just toss that entire labyrinth out the window? This is where the Metamorf promise comes in. It aims to take that entire tangled web of tools and processes and just replace it with something clean, simple, and completely unified.
1. That's the number you need to remember. 1. That's it. One single file is all you need to define your entire language, top to bottom. No more juggling different tools, no more writing glue code, no more build system headaches. Just one file.
So that entire maze we just talked about, it gets boiled down to just 2 steps. It's almost hard to believe. Step 1, you define everything about your language. Its keywords, its grammar, all the logic, inside a single .mor file. Step 2, you run a single command to compile a program written in your new language. That's it. We went from dozens of steps down to 2. And this quote from the docs, it just nails it. The first 2 parts make sense. No glue code, no build system. But that last part, no escape hatch, that's the real game changer. See, other tools will help you define the easy parts, the grammar, and then they basically say, all right, good luck. Go write all the really hard logic in C++. Metamorf says, nope. Everything you need is right here inside this one unified system. So how is that even possible? I mean, how can one single file contain an entire language factory? To get our heads around that, we need to basically perform an autopsy on that all-important .mor file and look at its anatomy.
Well, it all starts with the tokens block. You can think of this as literally teaching the compiler how to see. Before it can understand the meaning of a sentence, it has to be able to recognize the individual words and punctuation marks. This is where you tell it about your keywords, like if or for, your operators, like plus or minus, and what a comment looks like so it can ignore it.
Okay, so once the compiler can see all the little pieces, the grammar block teaches it how to understand structure, how those pieces fit together to form valid sentences. This is where you lay down the law for your language. You define the rules for what makes a valid statement or how expressions should be formed. It's basically the blueprint for turning a flat stream of words into a meaningful, structured tree. Next up, we've got the semantics block. Because, you know, a sentence can be grammatically perfect, but still be complete and utter nonsense. This block is the logic check. It teaches the compiler about actual meaning, how to manage variables, how to check that you're not adding a number to a word, and how to understand scopes. It makes sure your code isn't just structured correctly, but that it actually makes logical sense. And that brings us to the final piece of the puzzle, the emitters block. After your code has been seen, understood, and checked for meaning, this is where the magic really happens. The emitters take that validated logical structure and translate it into something a computer can actually run, a native executable file for Windows or Linux. So, okay, we've seen the core components inside that one file, but how does Metamorf actually use them? This is where we get to this really clever and elegant idea. It's basically a compiler that builds itself, using your file as the instruction manual.
It all works in two distinct phases. First is the setup phase. This is where Metamorf reads your .morph file. But it's not compiling your user's code yet. No, it's using your definitions to build a blueprint for a brand new compiler, one that's perfectly tailored for your language. Then, and only then, comes the compilation phase, where it takes that freshly made blueprint and uses it to compile actual programs.
And if you look at the actual pipeline, you can see exactly how this works. It's a perfect one-to-one map. The tokens block you wrote, that directly drives the lexer. The grammar block, that powers the parser that builds the syntax tree. The semantics block handles the validation, and the emitters block drives the final code generation. Each part of your definition file directly controls the stage of the process that turns source code into a runnable program.
Now, here's the part that, for me, elevates Metamorf from just a very clever tool to something kind of revolutionary. The language that you use inside that .morph file to define everything, well, it isn't just some simple config format. It's a full-blown programming language itself. This phrase from the source material says it all. Turing-complete by design. In simple terms, that just means it's a real, universal programming language. It can solve any computational problem. It's not a limited configuration file, it's the real deal. So what that means is when you're defining your grammar or your emitters, you have access to the whole shebang. You can use variables, you can write while and for loops, you've got if-else conditions, you can even define your own functions and use recursion. And the most crucial part is at the bottom there. You get all of this power without ever needing to escape to a different language to handle the tricky parts. It's all right there. And that really sums up the whole design philosophy here. You can use simple, clean, declarative rules to define the what, the basic structure of your language. But you can seamlessly switch over to powerful, imperative code to handle the how, the complex, custom logic needed to make it all work. They live together, side by side, as equals.
So, let's zoom out. When you put all this together, what is Metamorf, really? It's not a language. It's a tool to create languages. Think of it like a blank canvas and a full set of paints with all the brushes you could ever need. And this final quote, I think, just captures the spirit of the project perfectly. Metamorf doesn't really have any built-in ideas about what a variable or a function should be. It just gives you the raw mechanics, the tokens, the rules, the scopes, the code builders. It's up to you, the designer, to use those fundamental mechanics to create meaning.
Oh, and there's one more killer feature. Every single language you build with Metamorf automatically gets C++ interoperability baked right in, for free. You don't have to do anything. Your shiny new language can seamlessly call C++ code and use powerful C++ libraries right out of the box. It's a huge bonus.
So there you have it, Metamorf, a complete language factory in a box. It takes one of the most famously difficult areas of computer science and makes it accessible, powerful, and totally unified, which really only leaves one last question for you to think about. What language will you build?